Hi, welcome to the On Maths prediction for the AQA Maths GCSE Paper 2 higher tier. Enjoy! Hi, I'm Chris Gilpin from On Maths. Now, what we do for this prediction is we take off all of the questions that came up in the Paper 1 and we look at the remaining topics and see how often they've come up before, both on the new GCSEs and on the old GCSEs, and we make a prediction. Now, like I said on the Paper 1 prediction, this is only used as part of your revision and not the sole purpose of your revision. So don't just look at this and leave it at that. However, as you might have seen with the Paper 1 questions, quite a few came up across the different exam boards, but our predictions get more and more accurate as we go on, because obviously we now have seen the Paper 1, so you can make predictions for the Paper 2. All of our questions, all the questions you're going to see on this paper, you can do online on our website, onmaths.com. And if you go onto the website for free, you can either not sign up and just do the paper, and that's absolutely fine, or you can sign up and it will save your scores so you can try it multiple times, see if you can improve the scores. The onmaths.com also has topic busters, so you can practice every single topic. It also has demon questions for the harder style questions, and they're short little exams. They're only, I think, 20 marks, but they are just the toughest ones. And there's a whole load more things on the site. A new thing we're about to launch, so probably by the time you've seen this video, we have launched it, is the Revisionator. Now the Revisionator is only skills-based questions, so no difficult questions, we leave that for the demon questions. But what we've managed to do is take off all the topics that have previously come up and allow you just to revise a random selection of skills-based questions that might come up. So if you use the Revisionator, it will allow you just to focus on the topics that you need to focus on for the exam. So we're really excited to launch that. If you're watching this as soon as it comes out, it might not be launched yet, but hopefully it will be launched next week. So really looking forward to that. If you've got any questions or comments, please leave them in the comments tab below. If you like this video, please click like. And if you want to see more videos from us, especially the Paper 3 prediction, please click subscribe. I hope you enjoy. Okay, so we're asked to do a front elevation in this shape. Now, it's important to realise with front elevations or side elevations or even plans, you don't do any 3D, you literally draw it in 2D. If you try and do any 3D diagonal lines, you'll instantly lose marks, because when you're asked to do an elevation, it means you're directly straight onto that shape, so you won't see any 3D sort of lines coming off it. So when we're standing where the arrow is with the front, all we can see is this bit here. That's the only thing we can see. So it will look like this. Now, I'm not able to draw accurately here, but the width of it will be the same width as at the back here, so it would be 4 centimeters. So I draw it as 4 centimeters. The height of it would be the same height as this, so it would be 6 centimeters. So I draw a rectangle, perfect rectangle, which is 4 centimeters wide and 6 centimeters tall, and nothing else. You won't be able to see anything else. So all of this you wouldn't be able to see, neither would you be able to see any of this. Okay, so we're asked to write 88 as a product of its prime factors. So the first thing to do is write 88, and then we have two shoots coming from it. Now I need to find out which two numbers times together to make 88. Now a little tip, if you've got an even number, always pick 2. So 2 times 44. Now whenever we get to a prime number, we always circle it, because that's finished. So 44. Get another 2 out of that, we'll divide another 2 out of that, so 2 and 22, 2 and 11. Now 11 is also a prime number, and when you're left with just prime numbers, then you write your answer out like this. Now if you're also asked to write it in index form, that means instead of 2 times 2 times 2, you've we're going to write 2 to the power of 3 times 11. Now don't work that out because that will give you 88. So 2 cubed times 11 is 88. Okay, so this question says that Kaylee is painting a wall, and it shows us the dimensions of the wall, which is 6 meters by 4 meters, and it shows us each tin of paint covers 2 meters squared and costs £1.70. And it says how much will it cost Kaylee to fully paint the wall. So the first thing we've got to work out is the area of the wall, and the area will be 6 times 4, so base times height, which is 24 meters squared. Next thing we've got to work out is how many tins of paint we need. So the amount of tins, well, we've got to cover 24, and each tin of paint covers 2 meters squared, so it's going to be 24 divided by 2, which is going to be 12 tins of paint. Now it says the cost of each tin of paint is £1.70, so we're going to work out the total cost by doing the 12, because we need 12 tins of paint. We're going to times it by 1.7, or £1.70. So 12 times 1.7 is 20.4. And just remember, in money, you need to have it to 2 decimal places, so it's £20.40. With two-way tables, we've got to use the totals to work out the missing numbers. So a nice place to start is this box here. If we have a look, we've got a total of 46 people with brown eyes. 23 of them are female. So all you need to do is 46 and take away the 23, and that leaves 23 left over. Now let's have a look at a nice easy one. Right, green eyes, that's a nice easy one there. We've got 48 in total, and 27 females with green eyes. So we want to do 48, take away 27, and that leaves us with 21. Now if we have a look at this one, we have 23 females with 23 males with brown eyes, 18 males with blue eyes, and 21 males with green eyes. And we assume that there weren't any others because they're not in the table. So we add those together, and that gives us 62 in total. And let's have a look at this one maybe. So we've got 62 females altogether, and we've got 27 of them have green eyes, and 23 of them have brown eyes. So we take the 23 and the 27 away from 62, and that leaves us with 12. And we can just check that. We can do 23 plus 12 plus 27, and it equals 62. So we know that's right. With that one sorted, we can get this one. And if there's 18 males with blue eyes and 12 females with blue eyes, that means there's going to be 30 altogether. Now this total is either the total of these ones or the total of these ones, and they should give you the same number. Don't add the blue and the green ones together, so it's only one of them. So 46 plus 30 plus 48 is 124. And let's just check that. 62 plus 62 is also 124. So don't ever write down 248 because that's not correct. So in total there are 124 people whose eye colour were checked. With best value questions, which this is one of, there's normally multiple ways of doing it. Either you get the price per item, or you get how much of the item you get for 1 pence, or you get them to so that they're the same amount of items and then you compare the prices. Now this one asks for the price per tissue, so that's the way we've got to answer this question. So we're going to have tissues on the left hand side and price, and I'm going to do it in pence because it's normally a lot easier to work out when it's in pence. I'm just going to draw a line down the side. So we're going to start off with the box of 24, and it costs 802 pence. Now to get one tissue, I'm going to divide both sides by 24. So if I divide both sides by 24, I get one tissue. So I do 802 divided by 24, and I get 33.416 recurring. Okay, let's try the next one. So that's one done. In fact, if I draw a line, then I can show that I've done that. Okay, so the next one is 20 tissues, and that costs 689 pence. So this time I'm going to divide both sides by 20, so I know how much one tissue costs. So 689 divided by 20 on the calculator, and I get 34.45 pence. Okay, and the last one, let's draw our line. So the last one's 15 tissues, and it costs 538 pence. So this time I'm going to divide both sides by 15 to work out one tissue. Okay, so 538 divided by 15, and this time I get 35.86 recurring. Okay, so first of all, let's get the price in. So it says rounded to 2 decimal places. Okay, so this first one is 33.42, because that one moves up. The 20 tissue box is 34.45. And the last one is 35.87, because that 6 would round up. So which one is the best value? Well, if you have a look at the 24 tissue box, it's only costing 33 pence, just over 33 pence, whilst the 20 tissue box costs over 34 pence, and the 15 tissue box costs over 35 pence. Well, which one would you rather buy? Well, I'd rather buy the one that the tissues cost the least. So the best value is the 24 soft tissues. Now, in your answer, make sure that you write exactly the same as in the question, so that it's absolutely clear which one that you think is the best value. Now, if you worked the other way, if the question didn't specify how to do it, and you were working out the amount of tissues you get per penny, then obviously it works the other way. You want the biggest number because you want the maximum amount of tissues per penny. So just be a little bit careful of that. Okay, so question A is about reverse percentages. So in 2014 and 2015, well, let's have a look. So the sales went down between the two. So if we start off with 100%, and they went down 12%, what we're left with? Well, we're left with 88%. Now, as a multiplier, and this is the best way of doing this, 88% divided by 100, make it a decimal, is 0.88. Now that number, 0.88, is what we times the 2014 sales to get 2015. But in this question, we're given the 2015 sales, so we're given this one here. So we want to work backwards. So what we want to do is I'll get my calculator, 7,359 divided by 0.88, and that gives me £8,362.50. You've got to ask yourself, well, is that reasonable? Well, they went down by 12%, so it's natural that they would go from a number around just over 8,000 to a number that's just over 7,000. So I'm going to write the answer, £8,362.50. Okay, the next question says that the sales went up in 2016, or they have a target to get their sales up in 2016. What's the percentage increase? Now, percentage increase or percentage decrease, it's the same formula, is change over original times 100. So the change, well, that's going to be 12272, take away the 2015 sales, so that's that one there, 7359. So they're looking for it to change by 4,913. The original was at 7,359, and then we need to times by 100. So I'm going to divide that by 7359, times it by 100. And that gives me 66.7617, blah, blah, blah. So that's to the nearest percent, so that's going to be 67%. This is quite an unusual question because it's asking us to find the mean from a bar line graph. Now, what I would do is I'd first of all just start drawing a table for this information because I'm used to finding the mean from a table, so that's what I'm going to do. And so we've got pets, we've got the frequency, and we'll worry about the last column in a second. So 0 pets, the frequency is 6, 1 pet, the frequency is 10, 2 pets, the frequency is 6, 3 pets, the frequency is 6, and 4 pets, the frequency is 1. Now, to find the mean, you add an fx column, and I always call this, whatever is here, x, and I always call the frequency f, so it's the fx column, and you just times them together. So it's just a way of finding out those 6 that were 0, well, how many is that in total? Well, that's going to be 0. Those 10 that had 1 pet, how many pets is that in total? 10. Those 6 people who had 2 pets, well, how many pets are there in total? Well, 2 times 6, which is 12. There were 6 people with 3 pets, so that's 18 pets altogether. And there was 1 person with 4 pets, so that's 4 altogether. Then what you want to do is you want to add up the fx column, and we do that with a little e symbol, just means sum of. So I'm going to do that on the calculator now. So 0 plus 10 plus 12 plus 18 plus 4, which is 44. You also want to add up the frequency column, so sum of frequency. So it sometimes tells you in the question how many there are, so just double check that. So I'm going to add those together, so that's 29. Now, the mean is all of the stuff added together over how many there are. So you kind of want to swap these over. Okay, so it's 44 over, which means divide, 29. So 44 divided by 29. And it comes up with a fraction on the calculator, so just press S to D. And that equals 1.5172, blah, blah, blah. It asks for 2 decimal places, so to 2 decimal places that is 1.52, because that 7 moves that 1 up. Okay, so this question's about exchange rates, and this part here is quite important. If I just rewrite that to make it a bit bigger, this is basically saying that to get from pounds to dollars, we just need to times by 1.42. And you can get that by just dividing the right hand side by the left hand side. Now, 1.42 divided by 1 is just 1.42. So, the problem with this question though is that it wants the answer in pounds, so we'll need to convert both of these things into pounds. So we're actually going the other way. When we go the other way, instead of times, we just divide. So we're dividing both sides, or we're dividing dollars by 1.42 to get to pounds. So we've got $3,000, and we want to convert it into pounds. So we're going to divide it by 1.42, and I'm just going to type that into my calculator. So 3,000 divided by 1.42, and it's to the nearest pound 2112.6, and we'll round to 8. Obviously to 2 decimal places, because money is always to 2 decimal places. So it says also that that the laptop costs £2,500 in the UK, and how much cheaper is the laptop in the USA than the UK. So what we need to do now is we need to do £2,500, which is the price of the laptop in the UK. We're going to take away the £2,112.68. And on my calculator, I'm just going to type in 2,500, take away answer, and then press equals. And it gives me the answer of 387.32. So it's £387.32 cheaper. So when you have a right angle triangle and you're given two of the lengths and you're asked to find a third length, which I'm going to call x, then it's going to be Pythagoras. Be careful, because if there's an angle involved, either you're asked to find an angle or you're just given an angle on the side, then you'll be using trigonometry. So when we use Pythagoras, there are two methods that I know of to work it out. There's the algebraic method, which is a squared plus b squared equals c squared, and that's absolutely fine to use. I'm not going to use that method because if you're happy using that method, go on, use it, not a problem. The only thing to remember about that method is that c must be the hypotenuse. Okay, now I'm going to do a method that doesn't involve algebra at all for people who are not very happy with the a squared plus b squared equals c squared method. So my method comes with three steps. Step 1 is just square every number that you have and put the biggest one first. Okay, so I'm going to do 7.1 squared and I'm going to do 4.6 squared. So on my calculator, 7.1 squared, and that equals 50.41, and 4.6 squared equals 21.16. So step 1's done, I've squared them all. Step 2 is the only choice you have to make. You either have to add or subtract. Okay, now this is where we talk about the hypotenuse. The hypotenuse is the length that's opposite the right angle. So go to the right angle, go across from it, and that is the hypotenuse. So 7.1 is the hypotenuse. Now what's special about the hypotenuse and why it has a special name is it must be the longest side. So in step 2, have a think, well, if we add them, we'll get a bigger number. Well, the hypotenuse must be the biggest side. So when you're finding another side, not the hypotenuse, you will subtract. But if I was finding the hypotenuse, so I wanted a bigger number than the other two, then I would add. So I'm going to do 50.41 minus 21.16, and that's why in step 1 we did the biggest one first, because otherwise you'll get a negative number. So 50.41 take away 21.16, and that equals 29.25. Okay, and step 3 is a nice easy step, it's just root it. So with this one, I'm just going to press square root answer, and then I have, so I'm going to write that down, square root 29.25, and so that equals 5.4083, blah blah blah. It says it wants its two decimal places, so I'm going to write 5.41 because that 8 moves that 0 up by 1. Now, last step is just check it makes sense. Well, this being 5.41 means that the 7.1 is still the longest side, so we know we've probably got it right. Okay, so this question, it looks like a standard bearings question, but something you might notice is there's no angles in it. So if there's no angles in it, we need something else, and that something else is going to involve the right angled triangle here. So we can see there's a right angled triangle here, and we know that when we've got right angled triangle, we've got two sides, we can find an angle with trigonometry. I'm going to call this angle x. Now to find x, we need trigonometry, and to do trigonometry, we need to label the sides. So we've got the opposite here, which is opposite the angle we want. We've got the adjacent here, and we've got the hypotenuse here. Well, the hypotenuse is no interest. We're not looking for it, and we're not given it. So it's O and A. So writing Socator, Socator. Well, we're not interested in the H, so it's not going to be So, and it's not going to be Ka, so it's going to be Toa. So Toa stands for tan x equals opposite over adjacent. And the opposite is 47. And the adjacent is 72. Now we want to work out what x is, so to do that we want to inverse tan both sides. Okay, let's just scroll down. Okay, so on the calculator you want to click shift or the equivalent on your calculator and then tan, and then you press the fraction button, 47, and go down, 72. Just don't forget to close the brackets. Every time you click tan or inverse tan, it opens a set of brackets. Just make sure you shut them. Let's press equals, and that equals 33.1356, blah, blah, blah. Okay, let's have a look. So x is 33, but we still haven't got a bearing. What we can do is work out what this one is, and I'm going to call that y. So to work out what y is, it's going to be 33.1. Well, we're looking for nearest whole number, so let's call that 33. And then we're going to add the right angle here. Now, the reason I know this is a right angle here is because it says that he heads west and then south. So I know that both the angle here and the angle here are going to be right angles, because the angle between all four, north, east, south and west, all four directions are going to be right angles. So I'm going to add 90. And you can do this in the calculator or you can do it in your head. I'm going to do it on the calculator. 123. Okay, now bearings, something that we've got to remember, are always from north going clockwise. So it's always going to be like that. It's going to be that angle there. So to do that, we're going to do 360. We're going to take away the 123 because that's what we don't want. So on the calculator, 360, take away 123, and that's 237. So the answer is 237 degrees. So we're asked to find the amount of females who went on the log flume from a sample of 40, even though the amounts are out of 79. Now this is called stratified sampling, and it means that we've got a sample, which means a part of the population. Our population is 79, and we're just not going to ask everyone because that would take too long or cost too much depending on the circumstance. So we're only going to ask 40, but we want to make sure that we ask the people in the same proportions of male and female and the same proportions of who went on what ride. So we're looking at this one, which is the 11, because it says female who went on the log flume, and 11 people did. Now it's 11 people out of the 79, but we want a sample of 40. We're not looking to ask all 79, so we're not looking to ask all 11 of those people. So our sample as a fraction of the whole is 40 over 79. That's the fraction that we want of each of the 6 groups of people. The male who went on Big Dipper, the male who went on the log flume, etc., and the females who went on those rides. So the first thing to do on a stratified sample is find out the fraction of the amounts of people that you need. And we want that fraction of 11. So just times it by the amount that we're interested in. So I do that on my calculator now. 40 over 79 times 11 equals 5.5692, blah, blah, blah. Now, unfortunately, fortunately, you can't carve up a person, so there's no point of having 5.56 as an answer. You need to make sure that you have an integer as an answer if you're talking about amounts of people or amounts of things. So if you have a question just like this, where it's just talking about one of them, you can normally just safely round it. There are some types of question where you need to work out whether it works, whether when you add up all 6 options, it does add up to 40. Now sometimes it will add up to 39 or 41, and you've got to see the one that was closest to rounding the other way and round that the other way. For this type of question, because we're only looking at one and it's quite a simple question, I wouldn't go into that much detail. The easiest way of approaching this question is to understand what multipliers are. Multipliers, you always start off with 100%. You work out what's happening, so let's say we're adding 40%, and then you work out the final percentage, which is 140%. The final thing you do is just convert it to a decimal, so divide by 100 to make it 1.4. That means you can multiply any number by 1.4 and it will go up by 40%. So in this question it says we have Billy, we have James, and we have Sam. And we're told that James collects 40% more sand than Billy. So he's got 40% more. We're told that Sam collects 20% more sand than James. So he's got 20% more. By what percentage has Sam got greater than Billy? Okay, now the obvious answer is 60. And if you write 60, unfortunately, you're not going to get the right answer. The way of doing this, as I said, is to understand multipliers. So, we imagine Billy starts off with 100%, and he's gone up by 40%. So that means he's now got, or James has 140% of what Billy has. Now, as a multiplier, that's going to be 1.4. So whatever amount Billy has, we're going to times that by 1.4 to get James's amount. Then, James then has the 100%. We add 20% on to work out what Sam has, which is 120% of what James has. As a multiplier, that's going to be 1.2. So we're going to times James's amount by 1.2 to work out Sam's amount. Now the problem is we don't know what the amount is, but we do know what we're going to do to it. We're going to times 1.4, then times 1.2. So if we get our calculator, or if it's on a non-calculator paper, then you have to do this the long way. And I type in 1.4 times 1.2. And that will tell me in total what I'm timesing Billy's by to get straight to Sam's. Like so. The answer to that is 1.68. Now that's as a decimal. If I convert that back into a percentage, that means Sam, if Billy has 100%, that means Sam has 168%. So therefore, Sam has 68% more than Billy. Now, if you're adamant the answer is 60, you need to go through this, because this is why this is such a high topic. It's understanding that actually it's not going to be. And the government, with all their statistics, all the time use this, and people think, oh, it's 60%. It's not. It's 68% for this question. Okay, so whenever we're asked to find an inequality or draw an inequality onto a graph, always draw the line but without the inequality in it. So instead of x is greater than or equal to 5, always draw the line x equals 5. If it can be equal to it, it's a solid line. If it can't be equal to it, it's a dashed line. Okay, so it's x equals 5, and I'm going to draw a solid line. So where does x equal 5? Well, x equals 5 here, and here, and here. And in fact, anywhere along that line, it's just a vertical line up, and that's the line x equals 5. And it's really important to remember which way around it is. Whenever you have x equals something, it's always a line from top to bottom. When you have y equals something, it's always a line from left to right. Okay, that's the line x equals 5, but it's asked us to mark the region in the inequality with an R, so it's either going to be to the left or the right of this line. Well, it says that x can be anything that's greater than or equal to 5. So x could be 5, 6, 7, 8 on this graph, okay, because obviously it only goes up to 8. So anywhere this side of the line is absolutely fine, so I'm going to mark my R there. And actually sometimes the exams ask you to shade it in, so I just shade in that right hand side of the graph. Sometimes you shade in what you don't want, and if I was shading in what I didn't want, obviously it would be on the left hand side of that graph. Right, when working with bounds, the easiest way of answering the question or thinking it through is just to do a quick number line, put the number that's been rounded in the middle, and try and figure out what the next one down is. Well, it's to the nearest 5, so the next one down is going to be 80. Now we could do the next one up, but it's asking for the lower bound, so we're only interested in the lowest possible values. Now, the next thing is to work out what the cutoff point was. Why was it rounded to 85 and not 80? At what point did it need to be higher then? Well, the point at which it needs to be higher is halfway between the two, which is 82.5. So that's our lower bound for the 85. Then just repeat the process for the 160. So we've got 160 in the middle. And the next one down would have been 155. And then when we draw the line, well, it's going to be 157.5. Now, what many students would do is just look at the number. Well, the area is going to be 85 times 160, and that's what the area is going to be. But we know that the 85 could have been 82.5, and the 160 could have been 157.5. And that would give the lowest possible area. So if I get my calculator out, 82.5 times 157.5, and that gives me 12993.75. And it doesn't ask me to round it, so I'm just going to write down the exact number. Now be careful, with areas we're timesing them, so we want them both to be small, but if you were to divide them, sometimes you actually want the upper bound of one of the values, but for area you want them both to be as small as possible to give us the lower bound for the area. Okay, so this question looks quite simple, but actually it's going to take a bit of time to sort out. So first thing I'll do is do a little sketch. I'm going to do it up here. Since the y's are mainly negative, in fact are negative, both negative, I'm just going to show the bottom of the graph. So at point 7, we're at minus 17, which I'm going to say is here. It's a sketch, so it doesn't have to be perfect. And at point 19, we're at minus 11, which I'm going to say is here. Okay, this is called line AB. Now we're asked for the perpendicular bisector. Now perpendicular means it's going to hit that line at right angles. Bisector means it's going to cut it right down the middle. So I'm going to start off at the middle of the shape and draw a quick sketch there, like that. Okay, I'm going to call this M here, and I'm going to call this line C, just so I can reference it in my working out, and it makes it a bit clearer. Now, there are two things I need to find out to find out the equation of point C. I need to find the gradient of point C, and I need to find the y-intercept. The gradient is going to be the first thing I'm going to have to find, and then I can work out what the y-intercept is, and then write the equation of line C. So, two things I need to work out for line AB is the gradient. So the gradient is going to be change in y over change in x. So the change in y is minus 11 take away minus 17, and the change in x is 19 take away 7. Okay, so we've got minus 11, and then effectively plus 17, which is 6, divided by 19 take away 7. Okay, 19 take away 7 is obviously 12, so 6 divided by 12, which is a half. So the gradient of that is going to be a half. Okay, next I need to find the midpoint, because we know that that's also a point on line C. Okay, so the midpoint is going to be the average of the x's, so 7 plus 19 over 2, and then the average of the y's, so minus 17 plus minus 11 over 2. So we're basically just finding the halfway points. Now, obviously 7 plus 19 is 26, divided by 2 is 13, but you might have just noticed that 13 is halfway between 7 and 19. Same with the others. Obviously, we could do the same thing. Halfway between the two of them is going to be minus 14. Okay. Now, you might be wondering, well, why did we find the gradient of line AB? Well, perpendiculars have a kind of weird connection where if you multiply both their gradients, it equals minus 1. Now, the way we use this is to convert a gradient to a perpendicular gradient. We do two things. We find the reciprocal of the gradient and we times it by minus 1. So to find the gradient of line C, what we're going to do is flip it. So the reciprocal of half is 2 and times it by minus 1. So it's going to be minus 2. Now, a way of checking that is if you multiply the two gradients together, you should equal minus 1, which a half times minus 2 is minus 1. So we've got the gradient. Now we know that a formula for the equation of line C is y equals mx plus c. We actually know the gradient and we know a point on that line, which was the midpoint of line AB. So we're going to feed in the coordinates. So it's minus 14. We know what the gradient is, minus 2. I'm going to put this in brackets, times the x coordinate, which was 13, plus c. And we just solve this to find out what c is. So minus 14 equals, and that's going to be minus 26 plus c. I'm going to add 26 both sides. And if this is on the calculator, then obviously always use your calculator to be sure. So it's going to be 12 equals c, or c equals 12. So therefore the equation is in the form y equals mx plus c. It's going to be y equals minus 2x plus 12. So what this question is asking us to do is find the inverse function. That's what the f to the power of minus 1 means. And there's a really easy way of doing this. If we rewrite the function as y equals 4x minus 5, to find the inverse of it, we just literally swap the y and the x around. So x goes here and y goes here. Then the task is to try and get the try and get the y equals. Okay, try and make y the subject. So I'm going to put my lines down. So the first thing I need to do is add 5 to both sides. So we're going to have x plus 5 equals 4y. And next thing I need to do is divide by 4 both sides. And the way of doing that really is just with a fraction. So y is x plus 5 over 4. Now we made up y. Y represented the function initially, and then it represented the inverse function essentially. So all we need to do is finish that off. So f to the power of minus 1 of x equals x plus 5 over 4. If I just put that into the answer box. Now there are other methods, but I've always found just writing y equals and swapping the x and the y around and making the y the subject by far the easiest method. But if you've got a different one and it works, stick with it. Now there are two things you always want to try and get rid of when you're rearranging equations or formulas. The first thing is fractions. So this fraction here we want to get rid of, and we do that by timesing both sides by y minus 5. So I'm going to write out the equation again just to make it a bit bigger. And we can imagine that there's brackets around the top and bottom of this, and that sometimes helps us to answer the question. I'm going to put my lines down. So the first thing I want to do is times both sides by that y minus 5. And you must do that. You can't access the numerator of the fraction otherwise. So this ends up with being x brackets y minus 5. And on the right hand side it's just the same numerator but without the denominator. Now I said there were two things you've got to get rid of. The first one's fractions, the second one is brackets. You've got to break them open. So we're going to times out these brackets. So we're going to have xy minus 5x. And the right hand side hasn't changed at all, it's just 10 minus 3y because we haven't done anything to both sides. So what I want to do is try and get all of the y terms to the left hand side and all of the other terms, so the x terms, the number terms, or whatever, on the right hand side. So I'm going to add 5x to both sides, but I'm also going to take away, add 3y to both sides as well. So I'm doing 2 in 1 here. So it's xy plus 3y. And on the right hand side we've got that 10 that hasn't moved plus 5x. Okay, when we have this situation where we've got the brackets gone away and everything is, all the y's on the left hand side, and y is what we're looking to do it in terms of, what we want to do is factorize it, so we've just got a single y. So y on the outside, x plus 3. Now I know I said I wanted to get rid of the brackets, but we need the brackets here to be able to get y on its own. And the last step here is we just divide both sides by the x plus 3. So we get y on its own. So we get y equals 10 plus 5x over x plus 3. So let's put that into our answer box. Now it can be either way around here, it could be 5x plus 10, that's absolutely fine, still the right answer, over x plus 3. Now there are a couple of different methods for working this question out. What you could do is just draw a line down the middle and split it up into two right angled triangles, and then use trigonometry to find half of BC and then double it, and that's absolutely fine. I don't ever hesitate when there's a cosine rule to be used, so I'm going to do the cosine rule method, but either one will give you the right answer. So it's an isosceles triangle, so it's 6 centimeters on this side, so we know it's going to be 6 centimeters on this side, and we're given A, well that's a bit of a hint that it wants you to use cosine rule, and so I'm going to call this one little a, this one little b, and this one little c. So the cosine rule says that it's a squared equals b squared plus c squared minus 2bc cos a. And any capital letters are angles and any lowercase are always lengths. So a squared is going to be 6 squared plus 6 squared minus 2 times 6 times 6 times cos 100. Okay, and I can just type that into my calculator. So 6 squared plus 6 squared minus 2 times 6 times 6 times cos 100 equals, and so a squared equals 84.502 blah blah blah, and I'm doing the little dashes after the number to show the examiner that I'm keeping it into my calculator, I'm not going to round it. So a is the square root of that, so I might as well just show the examiner that I'm doing that, so I'm square rooting it. So what I'm going to do is just press the square root button on the calculator and then press answer equals, so a equals 9.192 blah blah blah. So to 2 decimal places it's 9.19. Now there's multiple ways of doing this question, there's loads of strategies out there. I'm just going to show you the method I do. I get the coefficient of the x squared, or in this case y squared, and times it by the number at the end. So that's going to give me 24. I then write down the factor pairs of that, which is going to be quite a few. It's 3 and 8, 4 and 6. And work out which of those adds together to make the coefficient of the y. So which of those adds together to make 11? Well, it's these ones, add together to make 11. I then rewrite it, but instead of that plus 11y, I'm going to write plus 3y plus 8y plus 12. So I haven't changed it, I've just split it up into 3y and 8y. Next, I'm just interested in factorising this bit, and then I'm just interested in factorising this bit. So I'm going to factorise the left hand side. Well, there's only a y that I can divide out of both of those, so it'd be 2y plus 3. And here there's going to be 4, so 2y plus 3. Now if you've done this correct, the two brackets here and here should be the same, and you should end up with a letter and a number there. Now the blue ones go together to form a bracket, so y plus 4. And that other bracket that we underlined in green, we just write that once. So our answer to this question is y plus 4, 2y plus 3, and you can write it in any order. Now there's loads of different methods of doing this. This by far for me I've found is the easiest to explain and the easiest to do. But if you have a different method, some people do trial and improvement, just keep trying different numbers. It depends on how easy the quadratic is. When you have the coefficient of the x squared being a non-prime number, that can get quite complicated quite quickly. Okay, so this question seems really complicated because the just sheer amount of words, but actually it's quite a simple question when you get your head around it. So the first question, we're looking at a bag or 2 bags of letters and 1 bag of numbers. And so there are 26 letters in the alphabet, so there's 26 options for this first bag. There will be 26 options for the second bag, and numbers from 0 to 9. Now we've got to be careful here because 0 is counted, so there are 10 numbers in that bag, because there's 1, 2, 3, 4, 5, 6, 7, 8, 9, but there's also 0, so that's 10 in total. And to get the amount of combinations, all we do is 26 times 26 times 10, and we'll have a calculator for this, so 26 times 26 times 10, which is 6,760, which seems quite a lot, but there we go. This next one is, so he wants to use 4 digits but limit the combinations, so we just got to read the question. His letter bags now contain the letters A to F, so that's A, B, C, D, E, F, which is 6, so these both will contain 6, and only contain even numbers greater than 0. Now these are the same bags as before, so we only had the numbers from 0 to 9 before, so the even numbers that are greater than 0, so it's 2, 4, 6, 8, so there's 4 combinations, so there's 4 numbers those can be. And so find out how many different passwords if they're arranged like this, so 6 times 4 times 4 times 6, so 6 times 4 times 4 times 6, which is 576. Now that might seem confusing that there's an extra digit to the password and yet less combinations, but if you think about it, there's significantly less letters and less numbers, so that's why it's a much lower number than part A. There are a few different ways of answering this question. The easiest way, especially for the way this question's set out, is to count the squares. So first of all, let's have a look and see what range we're doing. We're doing from 10, so from 10 to 40. So we need two things. We need to know, first of all, how many big squares, and we might as well count big squares, there are between those two, 10 and 40. And we need to know how many there are in total. So let's just have a count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So that's 11 tools. That's going to be 22 in that rectangle. That's going to be 10 high. So that's going to be 10 big squares. 1, 2, 3, 4, 5, 6, 7. So that's going to be 14 big squares. And this little section here is 1, 2, 3, 4, 5, 6. So I can use a calculator if it's on the calculator paper. So let's add those together, and that's going to be 52. So there's 52 in total in that middle region. But we need to know how many big squares there are in total. So we go count the other ones. So 1, 2, so that's going to be 6, so that's going to be 12. And that's the same height, so that's also going to be 12 because it's 6 and 6. So we're going to add the two 12s on. So there's 76 altogether. So total is 76. So it says it wants it to 2 decimal places. So it doesn't want it as a fraction, because as a fraction it's 52 over 76. So 52 divided by 76 is going to be 0.6842 blah blah blah. So that's going to be 0.68 to 2 decimal places. Now what you could have done is worked out the areas of each of the bars to get something that's maybe proportional to the frequency, and then done it that way. But if you can count the squares, it's just much easier and quicker. And sometimes you've got to sort of count half squares or little squares and find a way of doing that. But that's absolutely fine. When you're working with proportions, the actual amounts don't matter.
To simplify a fraction, you need to divide top and bottom by something. So if I just try and divide top and bottom by something now, I need to find something that all 6 terms have in common. Well, there is nothing that all those terms have in common. So the way of starting this is to factorize the top and bottom, so put them into brackets, and then something will turn up. So let's factorize the top. So I know it's going to be x at the start. I need 2 numbers that add together to make 12 times together to make 35. Well, that's going to be 7 and 5. Then I need to factorize the bottom. Now, a little bit of a cheat here. I know one of them will be the same. So either one of them is going to be x plus 7 or one of them is going to be x plus 5. So I need 2 numbers to add together to make the 10x times together to make 21. Well, I know that 5 doesn't go into 21, but I know 7 does. So x plus 7 and x plus, well, to make the 21 and the 10 needs to be 3. And all you need to do is divide top and bottom by, let's do it top and bottom. Get rid of that. Ugh. So all I need to do is divide top and bottom by x plus 5, x plus 7 even. And what that does is just gets rid of that and gets rid of that. The fraction stayed the same, but now it's x plus 5 over x plus 3.
Okay, there's quite a few different ways of doing this question. I'm going to do this with a tree diagram, but you don't need to use a tree diagram for this question. I just find it a lot easier. So we're going to first of all understand that when you take 2 tiles, you can't take 2 tiles. You take 1 and then another 1. Okay, so you move away from this idea of being able to take 2. You can't. You take 1 and then you take another 1. So the first pick can either be an 8, a 10, or an 11. So it's an 8, a 10, or an 11. And then the next pick, well, if you pick an 8, you can pick another 8, a 10, or an 11. If you pick a 10, you can only ever pick an 8 or an 11, because there's only one 10. And then 11, you can pick any of the 3 again. Okay, so with 8 you can pick another 8, 10, 11. With a 10 you can pick an 8 and 11, and that's 8, 10 and 11. Okay, now the most important thing we realise is let's work out which outcomes will end up with the second tile. Okay, and we should probably label this. This is the first tile and this is the second tile. So which outcomes end up with her having a larger second tile? Well, this outcome here, 8 and then 10, 8 and then 11 will. If you pick a 10, then you can pick an 11, and that's larger. And if you pick an 11, you can't get a larger second tile. So there's 3 outcomes you can get with this, with the second tile being larger: 8 and 10, 8 and 11, and 10 and 11. Okay, next we need to work out the probabilities. Well, all of the first probabilities are going to be 1 out of 7, because there's 7 tiles. Okay, so the chance of picking 8 is 2 out of 7, because obviously there's 2 8s. 1 out of 7 for 10, and then 4 out of 7 for 11. Okay, next, if you picked an 8, then there's only 6 left, and there's 1 10. So that's going to be 1 over 6. And I'm only going to be working out the fractions of the ones I'm interested in. So 8 and then 11. So if you picked an 8, there's still 4 11s left, but there's only 6 tiles. And finally, if you pick a 10, then there are 4 11s still, and there's 6 in total. Now, we work out the probabilities by multiplying the lines we went down. So let's have a look and see what lines we're going down for the first one. So we're going 2 over 7, and then 1 over 6. So it's going to be 2 over 7 times 1 over 6 times the tops times the bottoms. Okay, next line, we're going to do same line down here, but this time we go down here. So it's going to be 2 over 7, but this times 4 over 6. So that's going to be 8 over 42. And the final line, we go down the 10, and then we go down the 11. So it's going to be 1 over 7 times 4 over 6, which is going to be 4 over 42. Now, whenever we've got multiple outcomes, and it can either be this one, or this one, or this one, we add them together. Okay, so the probability is 2 over 42 plus 8 over 42 plus 4 over 42. So 2 plus 8 is 10, plus 4 is 14, so it'd be 14 over 42. And if you cancel that down, 14 over 42, you can half top and bottom, half top and bottom, and then I think you can divide them by 7, so you get 1/3. So the answer is 1/3 chance. Okay, so for this question, this is all about linear, area, and volume scale factor. So with this question, from B to A, we can work out the linear scale factor. So what do I times 5 by to get to 10? So the linear scale factor is going to be big divided by small, which is 2. Now the area scale factor is always the square of the linear scale factor. So we square it and it's going to be 4. The volume scale factor is always the cube of the linear scale factor. So we cube the linear scale factor and it's 8. So with this first question, it says cuboid B has the volume of 80. So if B has 80, the volume of A is going to be 80 times the volume scale factor, which is 8. So that's going to be 64 with a 0, so 640. And it's that simple. This one here, it says cuboid A has a total surface area of 440. So work out the surface area for B. Now this is surface area this time. So it's going to be 440. Now because we're going from bigger to smaller, we're going to divide by the scale factor. And it's the area scale factor we need, which is going to be the 4.
So we do 440 divided by 4, which is hopefully 110. And it's that simple. So you just got to remember that if you have a linear scale factor, you square it to find the area scale factor, and you cube it to find the volume scale factor. Okay, so this is a question on iteration, and we're given the iterative formula for a situation. Now, iteration is all about trying to find an answer, and it's a method in maths that bounces above and below constantly the correct answer, and it just gets more and more closer and closer, but it doesn't quite ever get there. It will just get more and more accurate the more times you do it. So we're looking for when to stop, and that's given here, just to 2 decimal places. So the formula is given here, and this is the only bit we need here, as well as this bit, the starting number. And in my calculator, I'm going to type in 5 minus, well, actually, no, I'm not. I'm going to press 2 and then equals. And the reason for that is it tells my calculator to use 2 if I use the answer button. Next thing I'm going to do is type in 5 minus square root answer. Now, when I press equals, the calculator will remember that the 2 is the answer and use a 2 here. Now, you might think that's a lot of effort just when I could have pressed a 2. But you'll see what the benefits are after this first run. So when I press equals, that gives me my first number, and if it comes up as a third or something on a calculator, just press S to D. So that gives me 3.585 blah blah blah. Now, the beauty of these modern calculators, is if I press equals again, it will use the 3.585 number and put it back into the equation. So all I need to do now is just press equals, and it gives me 3.1063 blah 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 blah. Again, equals 3.2375 blah blah blah, equals 3.2006 blah blah blah, equals 3.2109 blah blah blah, equals 3.2080 blah blah blah, equals 3.2088 blah blah blah. Now, you stop when you get the first repeat of the accuracy that you're looking for. So if you look, this is the first time I've got the same answer twice, 3.208 blah blah blah. So it says it wants the solution correct to 2 decimal places. Now 3.20 is not going to be the right answer, because if I have a look, the next one is an 8. So my answer will be 3.21. The first thing to notice with this question is that to find a distance of a velocity time graph, you've got to work out the area underneath the curve. Now, at A level, there are much easier ways of doing this, but we at GCSE have to do this using the trapezium rule. Now, the trapezium rule goes as follows. You're going to carve that curve, or the underneath of that curve, up into trapeziums to try and estimate, and this is what it asks us to do, the area underneath it, therefore the distance. So it says it will always give you hints about what it wants you to do. So it gives us a hint saying that it wants it between 2 and 10, but it wants it in 4 equal intervals. So if I do 2 and 10, so we can get started. Now let's have a look and see how many squares there are in between them. There's 8. So if we want 4 equal intervals, we're probably going to go up in 2s. So let's try 2s, and hopefully it will work nicely. Now we haven't created trapeziums yet, so let's create trapeziums now. So we're going to create trapeziums for these 4. There we go. Okay, let's try and get the heights of these trapeziums, and I normally draw it onto the graph itself. It's a little bit easier to get my head around.
So that's, I think that's 11. I think that's 6. And the height of this one is probably, because I've drawn it badly, I think it's 3. Height of this one is 2, and the height of this one I think is 3. And the width of them is 2, so all of them is 2. Okay, so we need to remember how to work out the area of a trapezium. It's half a plus b h. Now this is quite misleading because h actually using the trapezium rule is the width of the trapezium. It's because the trapeziums are kind of on their side. So h is always going to be 2 for these. So what I would do is just number the trapeziums that I'm doing. So I'm going to do number 1. Now number 1 is going to be half 11 plus 6, because A and B are the ones on the left and right of the trapezium, times 2. And I can use my calculator for this, so it's going to be 17 divided by 2 times 2. I don't know why I'm dividing by 2 and timesing by 2. It's just going to be 17, because the half and the 2 will cancel out. So the second one is going to be half, and this time it's 6 plus 3 times 2. Well, we know the half and the 2 will cancel out, so that's just going to be 9. The third one, the third trapezium, and if you want to, you can actually just number them on the actual thing itself to show the examiner, yep, this is the one I'm trying to work out. So that's going to be half, and what is it this time? 3 plus 2 times 2, which is just going to be 5. Let's just scroll it down a little bit. So the fourth one is going to be half 2 plus 3 times 2, which is also going to be 5. So to work out the total distance, 7 plus 9 plus 5 plus 5, 17, sorry. So 17 plus 9 plus 5 plus 5. I don't know why I'm using a calculator for this as well, but it's here, so we might as well use it. So it's going to be 36. Now commonly with this question you're also asked whether it's an overestimate or underestimate. If you have a look at the trapezium, this bit here and this bit here, we've counted that as area, and actually there's little thin strips down here. We've counted as area that actually isn't area, so this one will be an overestimate. If your trapezium goes the other way and it doesn't quite hit the curve, then it's going to be an underestimate. Thank you very much for watching this video. Hopefully you found it useful. Don't forget you can go onto our website onmaths.com, which I'm sure the link will appear above me, to practice this paper and practice other papers as well. We've got all the previous year's predictions as well, which might be useful. And also we've got the new revisionator coming out, so we're really excited. If you've enjoyed this video, please click like. If you want to see more from us, especially paper 3, please click subscribe. Thank you very much.